This is a second video on encapsulation. In the first video we talked about the mechanics of encapsulation and how you can accomplish encapsulation, and in this video I'm going to try to illustrate why we'd want to do encapsulation. The problem is we're going to run into a few different programming techniques here with the example that I've created that really are not related to encapsulation, so I'm going to try to point those things out. Alright, we have two basic classes here. I have created an exception class in valid time, and then I've created a class that is going to represent a time. So hours, minutes, seconds. I didn't go into date. This is just an example. So this is all we'll need for this example. In the init class, we run a check function for the minutes, the hours, the minutes, and the seconds. And if the hours, minutes, and seconds that are being passed into the init pass whatever these checks are, then we go ahead and create attributes inside the class for hours, minutes, and seconds. And if they don't pass whatever these checks are, then we raise in an invalid time. Now, down here we also have a string method, and there's something in here I'm going to have to point out that this is not part of encapsulation, but it is another technique that's worth pointing out. You can format numbers. This is something we haven't gotten into in any of the previous videos, something I'm not going to go into in any depth in this video, but you can format numbers using a .format command. This is a string, and the string has a .format method. So this string is going to have, in this case, I'm saying this is going to be a variable. When you put something inside of a brackets, this is going to be a variable, and this is going to be a variable. And then these two variables are separated by a colon, and these two variables are separated by a dot. What's inside the brackets then specifies what the formatting is going to look like. In this colon, O2D says this is going to be an integer, and I want it padded with 2 places. So I'm always going to display 2 digits for this decimal, no matter if the decimal is 1 digit or 2. So down here you can actually see an output. Now this value for hour is 1, but it displays it as 01. The value for minutes is 2, but it displays it as 02 because it's padded with those 2 digits. So there are 3 variable placeholders specified inside the string, and then in .format we pass it the actual variables that we're going to use. So self.hour, self.minutes, self.seconds. The number of variables you have over here has to match the number of paired brackets you have here, and then these brackets specify the formatting for these variables. So there are a lot of things you could go read about formatting if you wanted to. This is not going to be, again, the subject of this video, so let's move on from that. Now we have to define what these check methods are. So they're defined down here, and we have def check hours, def check minutes, def check seconds, and it just checks that hours is in between 0 and 24, minutes is in between 0 and 60, and seconds is in between 0 and 60. And if these are true, it returns true, and if those are false, it returns false. Notice that we have these decorators. Now decorators came up in a previous video on encapsulation. They're going to come up in this video, and then there will be a video on decorators. But this decorator is kind of an interesting one, static method. All 3 of these have the same decorator on them. That decorator means that these methods are static. What that means is, notice they don't have a self in here. There's no self comma hours, because the self is not needed. All I need to know is, are the hours here in between 0 and 24. I pass in the hours as a variable, and I just check to see if the hours are in between 0 and 24. I could have written this a different way, but I wanted to illustrate the use of the static method. I could have just put this as self and checked self.hours. In that case, it wouldn't be a static method, because I would be using, I would be using the self class variable. And if I did that, if I use self.hours down here, then I would have to rewrite my code up here appropriately. I chose to do it this way. I chose to just pass in hours, which comes directly into the init, and then pass them right to this function. So this function has no need to know what self is. Self hasn't actually even been declared yet or used before I call these checks. So static means that these functions are independent of the actual class instantiation. They're static, they're constant. You can change the instantiation, but these methods are not going to change. If you declare something like this without a self, you have to be careful how you do this, because Python assumes that the first variable here is self. So it would treat hours as self if I didn't put static method here, even though it's not named self. This is getting far afield from encapsulation, but alright, so hopefully that was somewhat clear. If you're going to have a static method, then you have to have this static method declaration up here. Alright. So, I call this time is not the best. Let's try instantiating time is not the best. So I'm going to try to instantiate this with 30 hours, 75 minutes, and 0 seconds. That should create an exception. So I put this inside a try except block, and when I do this instantiation, it should create an invalid time exception and print this didn't work. So we should never see print time for this one. Now I'm trying it again. I'm at 12 hours, 0 minutes, 0 seconds. That should work, so we should see print time 1. And then down here, well, we've already instantiated time 1. Down here, I'm changing the hours, the minutes, and the seconds for time 1 to 30, 75, and 0. This is the thing that I tried to do up here, which shouldn't work. Down here, I am directly accessing then the attributes of the class. Remember, encapsulation says that you shouldn't work directly with the attributes of a class. So this is something I shouldn't really be doing if you follow the sort of encapsulation protocols, but I'm doing it, and I can do it. So I'm directly setting time 1.hours, time 1.minutes, time 1.seconds, and you've done this before in your own programming, I'm sure. Set class variables, class attributes down in the main part of the program. I've done it in my videos, and I never told you that's something that you shouldn't do. Let's run this. And sure enough, for this one, you can't have 30 hours, 75 minutes, 0 seconds. So it says this didn't work. That did what we expected. This you should be able to do. You should be able to have 12 hours, 0 minutes, 0 seconds. So it prints out in the format we were expecting that time. But down here, when I set hours, minutes, and seconds by themselves, it allows me to do that. Now ideally we should have gotten a print. This should not work, because we shouldn't be able to do this. We shouldn't be able to have 30 hours as a time. That's not a valid time during a day. But we can, because we're overriding what the class intended by directly accessing these attributes. Okay, so now we go into encapsulation. And if you remember the first video, this is kind of the thing that encapsulation gets into. Okay. Going to Y part 2, we're going to take this code and extend it a little bit. So the init method here is exactly the same. Invalid time is the same. These methods for check hours, check minutes, check seconds is the same. But now I'm defining some getters and setters. So I have a get hour, which just returns self.double_hours. Notice that I have up here, I said these are exactly the same. I lied. I have made these private. And now I'm running the getters and setters. So I'm getting the hour. I'm setting the hours. Here I have a little print command that says I'm setting the hour. I'm getting the minutes, setting the minutes, getting seconds, setting seconds, etc. And then I'm defining hours, minutes, seconds with these getters and setters. And we have these decorators property. So again, we haven't talked a lot about decorators, but they keep coming up. We now have one way of setting a decorator up here by putting an @ sign in front of a static method, and then we have another way of specifying a decorator down here with this property decorator. We'll need another video on decorators, but just remember this is how you define getters and setters for a class using this property. Okay, so now I'm going to run this Y part 2. So the difference between this and the first one is we now have getters and setters. And down here, this is the same as before. This is the same as before. Here I'm assigning A, B, and C to time 1.hours, time 1.minutes, time 1.seconds, and then printing those. And then down here I'm going to set time 1.hours, time 1.minutes, time 1.seconds. And we're going to run Y part 2. Alright, so you know what? I missed something here, which I wanted. So I'm going to put a print here. And sorry, I don't know why I didn't have a print in the getters, since I'm clearly using them down below. And I want to point out again where I'm using them. Alright, let's run this again. And take a look at what happens. Alright, we instantiate time with 30 hours, 75 minutes, 0 seconds. And we go up here, that calls the init method. It does the checks. The checks are the same as before, and it checks to see if hours is in between 0 and 24. The hours is 35. So it's not, so this returns false. Because this is returning false up here, then this raises invalid time. And down here, invalid time sets that exception is set, so it prints out this. Oops, this didn't work. Then we try to instantiate time 1 with time again with 12 hours, 0 minutes, 0 seconds. We come up here, we check the hours, we check the minutes, we check the seconds. The hours is 12, that's in between 0 and 24, that's fine. The minutes is in between 0 and 60, that's 0 minutes. 0 seconds is in between 0 and 60. So these all return true. So this if is true, and then we set these private variables to hours, minutes, and seconds, and so those should be 12, 0, 0. And then we print time 1, which calls our string method, and notice that I've changed this a little bit and put the double underscores in front. So it prints out 12:00.00.00. Alright, now I can set A equal to time 1.hours. Now what this does is when I do this assignment, I need the value, or Python wants the value for time 1.hours. So when it does that, notice that this is not double underscore hours like we set up here. Remember how this works. When you ask for time 1.hours, it comes up here and says, oh, hours has a property of a getter and a setter, and since I want A to be equal to what this value is, I need to get this value. So it goes to the getter, and we print getting the hours. So this is where we're setting A equal to. Then we get the minutes, that's B equals, and we get the seconds, that's C equals. So when we do this A equals, B equals, C equals, that actually calls the getters for this class. And then we print A, B, and C. So notice it doesn't have the colon dot format, it's just 12, 0, and 0. It doesn't have the extra padding. We're just printing those variables out, and they are 12, 0, and 0. Oh, look at that. I have a PEP. Fix that. Okay, now, I haven't changed much. If I go look at then trying to do what I did before, directly setting hours, minutes, and seconds to 30, 75, and 0, well, I can do that. I shouldn't be able to do that, but I did do that. When I do this, now this is kind of the opposite end of what I did up here. When we set time 1.hours equal to 30, 75, and 0. Notice I'm not using the double underscore inside the class. These are private variables. So when I say time 1.hours here, I'm calling this decorator, which says, oh, you have a setter. They have to be in the right order, getter, setter. And so I'm going to call the setter, and it sets the hour. So it's setting the hour to 30, setting the minutes to 75, setting the seconds to 0. So here's where it prints those out, setting the hour, setting the minutes, and the variable minutes, setting the seconds, then the variable seconds. So notice how these two, how the getters and setters work with equal signs. When you're on the right hand side of the equal sign, you're calling the getter, and when you're on the left hand side of the equal sign, you're calling the setter. So we call the setters, and then we print time 1, and notice what the getters and setters do. In this case, the setters, let's look at the one for hours, sets the private variable double underscore hours to hour. So we've set now self that hour, double underscore hours to hour, and then when we call the string method, it prints that out, and lo and behold, we have set the hours to 30 hours. That's not desirable behavior, so we haven't really seen the use of encapsulation yet. We've just made a whole lot of code here. We've defined these getters, we've defined these setters, so we have all this code up here with these getters and setters and these private variables, and so far the behavior of this thing, when we're all said and done, is exactly the same behavior as we had before with much less code. So we should be asking what's the point, and this is the whole why part. The problem with this code is the same problem as we had with y par 1. We shouldn't be able to do this. This is not desirable behavior. Now, as a programmer, we shouldn't do it. We should know better than to assign hours to 35 and minutes to 75. But as somebody that's writing this time class, I shouldn't allow that to happen. So good coding would say, I shouldn't allow this to happen. All right, now here's where the getters and setters finally can be made use of. So, mostly the same code as I had before. The init is the same. Invalid time exception. String method is the same. The checks, same. Getter is the same. Well, I don't have the strings in there. The setter is different. So I've done a couple of things. One, I got rid of the print, I'm setting this thing. The other thing that I have done is I've done a check in here. So when we go to set the hour, I actually run the check again for hours, and if the check passes, then I set this private variable to hour. Otherwise, I raise invalid time. So this is the only difference between y part 3 and y part 2, and this is the why. This is the why we use all this code to run getters and setters. I do the same thing with minutes. I do the same thing with seconds. The behavior down here is going to be very similar to what we had before, with one significant difference. So I'm going to run this. The first one is exactly the same as we had before. Nothing has changed here. So we try to do this init. The init checks the 30 to 75 and says, nope, can't do that. Raises the exception invalid time and prints this doesn't work. This does work. Those pass through the checkers. But now look what happens when we try to set time1.hours equal to 30 and time1.minutes equal to 75, which is something that was perfectly valid in Y part 1 without all these getters and setters. When I do this in Y part 3, and I better do it apparently fairly quickly. 10 minutes ago I had an hour and a half left. Now 10 minutes later I have 15 minutes. Anyways, when we do this, we're trying to set time1.hours. So from the point of view of the programmer that's using this class, I'm just trying to set time1.hours. But from the point of view of the person writing the class, now when they try to set hours, I get to run this through my getter and setter. And if I go up to my setter for hour, as I said before, I can validate that they're doing the right thing. And so I run this check on hours, and if it's invalid, I raise invalid time, and bingo, it doesn't let me set time1.hours to 30. So a few things to notice here. One, as a person writing the class, I have a bit of work to do. I have to set up these init methods, but I had to do some checking. But the other thing I had to do is that for every attribute that I have, hours, minutes, seconds, I made those private, and then I had to write getters and setters for them. Well, now there was more to it than that. Not only did I have to do that, but I had to run all these checks. But here's the nice part. I do all this work in my class, but from the point of view of the person writing the code down here that's using my class, nothing has changed. This code is exactly the same as this code. So this is completely transparent to the end user, and that's the beauty of using encapsulation. Yes, it's work. And yes, you have to learn things about decorators and some such, and at first it seems a little bit disconcerting, but when you get used to using them, you can write these classes in a transparent way that the end user never knows that they're not using actually time1.hours. They're not setting an attribute time1.hours. What they're actually doing is calling a decorator, which then sets these private variables. And then you can do code validation. We can do data validation. There's all kinds of things you can do. So this is the principle of encapsulation, and why, and sort of the principle of, not why, sort of, this is why there is this principle of encapsulation in classes, so that you can make these kinds of checks work, and they're completely transparent to the person that's using your class. So to understand encapsulation, you have to look at it from 2 points of view. You have to look at it from the point of view of the person that's writing the class, but you also have to look at it from the point of view of the person, the end user, that's going to be using your class. And as that point of view, I have no idea what's going behind the scenes. It looks to me like I am setting some class attributes, and seems easy enough, and oh wait, I did something wrong, so I get an error thrown. Works beautifully from my point of view. Alright, now Y part 4. Another view of encapsulation. So I've written this hours, minutes, seconds class, and people like it. I've done a good job. They like the whole getters and setters. They like that it does all this data validation for them. They don't have to write any extra code. Notice that, here's another way to think about encapsulation. Suppose that I had written this class and people were using it and had written thousands and thousands of lines of code using my time class. Alright, it's a bit of an exaggeration, but let's pretend. And then somebody comes along and says, you know what, Darwin? I don't like the way you did this. I need you to change this so that I need you to change your code so that I can't set time1.hours to 30. So that wasn't part of the original specifications, but now somebody's come and changed the specifications. So I have all these lines of code out there, thousands and thousands of lines of code perhaps, that have all these uses for hours, minutes, and seconds, and now suddenly I need to rewrite all that. In the old days, I would have had to rewrite all this. But with Python, instead of going out and checking everywhere somebody has set time 1.hours to something, I can just completely rewrite the class using getters and setters, write the functionality into the getters and setters, and this code will never know the difference. Completely transparent. Alright, well, as long as the code is used correctly. Alright, so I'm going to change class time. Here's another view of encapsulations. Seriously? This thing's going to quit on me. Alright, sorry about that. I had to run and get my power cord. One of the things it did point out is I'm way over time on this video. So I'm 25 minutes into this thing. Alright. I've got this time class. It's become very popular. Somebody else wants to use it. But now, instead of having a 24-hour time format, they want a 12-hour time format with AM and PM. What am I going to do? Well, I'm going to rewrite my class. I'm going to add an optional AM PM and set it equal to none. So that's the default value is none. If it's not none, then I'm going to check to see if AM or PM is a string, and if it's uppercased as AM or PM. So I want this variable AM or AM PM to have the value either capital AM or the value capital PM. So I'm checking to see if that's the case. If it is the case, then I set this private variable AM PM to AM PM. And if this is not the case, so if AM PM is set, but it's not a capital AM or not a capital PM, then I raise invalid time. If AM PM is none, I just set AM PM to be that, the private version of AM PM, and then the rest of this is as before. I check the hours, minutes, and seconds, and set those private variables as I did before. Now, notice my check hours has changed. It's no longer a static method because I need to know if self.am or PM is set. So now I have a self variable. And if self.am PM is not none, then I should have an AM or PM. And I'm sorry, if self.am PM is none, I'm using a 24-hour format, and I checked for the hours in between 0 and 24. And if this is not none, then I'm using a 12-hour format, and I check for hours in between 0 and 12. So notice that up here, that in these two cases, I've set this variable. It's either set to none or set to capital AM or PM, or an exception is thrown. So there's those three possibilities. String method has changed. So if it's a 12-hour format, then, or 24-hour format, this is the same as before. If it's a 12-hour format, then I add on the AM PM. Remember that this thing right here is actually a string, so I can just add the string AM PM. Check minutes, check seconds is the same. Set hours is the same. Set minutes, same. Seconds. I have a getter and setter for AM and PM. You know what I should have done, and I didn't, now that I'm looking in my code, is I should check AM and PM down here when I'm setting AM and PM, and I didn't do that. I should have run the same check that I did up here on that AM and PM. I didn't do that. I'm not going to change it now. We're well over time in this video. I have getters and setters for hours, minutes, seconds, AM and PM. Now, here's the point of all this. This code, same as before, doesn't work. This code, same as before, doesn't work. This code, same as before, encapsulation, doesn't work. This code is new. So I'm trying to set this to 1:02 AM. That's a valid time, so that should work. Trying to set this to 1:02 and then ZZ. That shouldn't work. And then I'm trying to set this to 13 a.m., which also shouldn't work. So I should get 2 Danger Will Robinsons. I just watched that movie recently. We'll run this. And that's exactly what happens. Now, how is this related to encapsulation? I've thrown in AM, PM. I've thrown in all this extra code. Great. I mean, that's nice, I guess. How is this related to encapsulation? It's related to encapsulation exactly down here. Remember, from the point of view of the end person that's using my class, I'd originally written it on a 24-hour time format. And for the person that was using that, suppose my code got popular again, and now I've got thousands, hundreds of thousands of people all over the world using my time class because it's so amazing. They never know I changed it. Their code looks exactly the way it did before. Their code functions exactly the way it did before. But somebody that wants to switch to an AM, PM, 12-hour format can use my code also, and the end user is none the wiser. That's the way encapsulation should work. So the end user shouldn't be privy to those kinds of changes, shouldn't have to be privy. The end user shouldn't have to go and change their code up here for 24-hour format if I now want to include a 12-hour format. My code for my time class should validate that they are properly using my time class and do it in a completely transparent way. And to the end user, they're just trying to set hours, minutes, and seconds. They have no idea what my code does. My code does all the work behind the scenes with getters and setters. That is encapsulation. It's really a beautiful idea. I don't know if I've got that across in this video, but encapsulation is a wonderful thing in terms of writing code that other people can use, and transparency to the end user, and the ability to update your code without affecting the work that they've done. Great stuff. Love it.